Good afternoon, everyone. My name is Omar Ahmed from grade 9A, and today I'll be explaining to everyone stellar evolution, or the life cycle of a star. I'll be pointing out or summarizing each step of a life cycle of a star. And at the end of this video, I'll just point out some stuff or some points about the HR diagram of a star. So let's start. First of all, guys, let me point out to you what's stellar evolution. Stellar evolution is the process or lifetime of a star that changes over time. The mass of a star can affect its lifetime. For example, the smaller stars could live for a longer time, and the larger stars could live for a shorter time. The life cycle of a star. Stars go through a living cycle just like every living thing. It begins with birth and it ends with death. But it differs from living things or every human being or a plant or an animal because it lasts billions or trillions of years. Some stars that we see in the sky are already dead, but the light that reaches us it takes millions or billions of years or kilometers that travels. So the light we see it might be of dead stars. So stars go through 7 main stages. Stars they come through different masses and different types of masses, yeah. So massive stars they might transform at the last stage into supernovae, neutron stars or black holes, while averaging stars, not the massive stars like the sun, they might end up in a white dwarf. We all know that for sure, that one day the sun might end up in a white dwarf. Yeah. So no matter the size of the star, all the stars follow the same life cycle, the same 7 stages of stars, which I'll be explaining deep into this video. The giant gas cloud. This is the first step of the life cycle of a star. This is where the base of the star forms. This is where the star originates from a large cloud of gas. The temperature in this large gas cloud, is low enough for molecules to form. Some molecules, like hydrogen, they light up and they allow some astronomers to see them in space. One example of a giant gas cloud is the Orion Cloud Complex in the Orion system. We could see them, just like why I told you, because of the hydrogen that light up and they allow us or they allow astronomers to see them in space. This marks up the first step of the life cycle of a star. The second stage of the life cycle of a star, the protostar. This stage takes place when the gas particles in the molecular cloud run into each other. When these particles in the molecular cloud run into each other, heat energy is produced as a result. This heat energy results in the formation of a warm clump of molecules. This warm clump of molecules is referred as a protostar. The formation of protostars can be seen through infrared vision, because the protostars are warmer than any other materials in that molecular cloud. Many protostars can be formed in one cloud, depending on the size of the molecular cloud. As I said, protostars can be seen through infrared vision, and also it depends on the size of the molecular cloud, so the protostars can be formed into one cloud, many protostars. This stage of stellar evolution might last between 100,000 to 10 million years, depending on the size of a star being formed. Fun fact, protostars are also known as young stellar objects. The T-Tauri stage, the third stage of the life cycle of a star. In this stage, in the T-Tauri stage, it starts by a young star that begins to produce strong winds. These strong winds push away the surrounding gas and molecules. This allows the forming star to become visible for the first time in the life cycle of a star. For the first time, scientists or astronomers can spot a star in the T-Tauri stage without the help of infrared or radio waves. The T-Tauri phase or the T-Tauri stage lasts for about 100 million years. The main sequence phase of a star. During this stage, this is the stage where the star develops, where the core temperature of a star reaches the point where the fusion should start. In this process, protons of hydrogen are converted into atoms of helium. This gives off more energy than it requires, so the core of a main sequence star releases a tremendous or a huge amount of energy. During the main sequence stage, the star gets a solid shape. A star in the main sequence phase spends 90% of its lifetime During this stage, it fuses hydrogen molecules and it forms helium in its core. The Sun of our solar system is currently in the main sequence phase. Now let's proceed to the fifth and the most known stages of the star, the red giant. During the expansion of a star into a red giant, the hydrogen in the star's core is converted to helium. As a result, the core collapses on itself. This causes the star to expand. During this process, as the star expands, it becomes a subgiant star at first, then it proceeds to become a red giant. Red giants have cooler surfaces than main sequence stars, and because of this, they will appear red rather than yellow. If a star is massive enough during this process, it could become large enough and it could be classified as a supergiant. The fusion of heavier elements. During this stage, as the star expands, the star begins to fuse the helium molecules in its core, and the energy of this reaction prevents the core from collapsing. Once the helium fusion ends in the star's core, the core shrinks, so the star begins fusing carbon dioxide. This process repeats until the iron begins appearing in the core of the star. Iron fusion absorbs energy, so the presence of the iron causes the core to collapse. If the star is big or massive enough, the implosion creates a supernova. Smaller stars like the Sun contract peacefully into white dwarfs, while the outer shells of these stars radiate away as planetary nebulae. The last and final step of the stellar evolution of a star. Supernovae and planetary nebulae. A supernova explosion is one of the brightest events in the universe. During this seventh or the last process of a star, most of the star's material is blasted away into space, but the core implodes into a neutron star, which is mostly known as a black hole. We all know what's a black hole. Less massive stars like the Sun, they don't explode in this way, but instead their cores they contract into a tiny hot star known as a white dwarf. Even less massive stars than the Sun, the tinier stars, they don't even have enough mass to burn with anything, but just a red glow during their main sequence. These red dwarfs are difficult to spot, and they be remaining for trillions of years during this process. These, what I've summed up, are just the 7 stages of a life cycle of a star. A star might live for a long time and be smaller in size, and it might live for a shorter time and be larger in size. They are beautiful objects in the universe, and they require much of studying and much of observing. And guys, before I end this video, let me just give you some quick points about the HR diagram. It's called the Hertzsprung-Russell diagram. It's used by astronomers. It's a graphical tool used to classify stars according to some points like its luminosity, type, color, temperature, and even stage. It shows the relationship between stars and absolute magnitudes and luminosities versus some points like stellar classifications or temperatures. It's really helpful for astronomers at that time. So that's it guys, thank you for listening. That's all for my video and I hope you enjoyed. These are the 4 sources I've used: Wikipedia, Cosmos.com, Medium.com, and WesternWashingtonUniversity.com. Thank you for listening and sorry for having the video longer than the required time, which is 7 minutes, but I hope you enjoyed. Thank you once again. Bye.